So, welcome to day 2. Everyone's setting up for a big day ahead. Apparently, I've just been told we're going to have more people today than there were yesterday, so should be fun. Hello, I'm actually here with Terence Andrews, who is a resistivity chap, and he's going to tell you a little bit about resistivity. What is this? All this stuff here that's going on?
Right, it's archaeological prospecting equipment for archaeologists. Many people have seen pictures of people walking up and down grids in fields and stooping and sort of looking around. That would be field walking, where you're just walking along and looking for things. But if you want to know what's just below the surface, up to about this sort of distance, then you can use a resistance meter or a magnetometer, magnetic radiometer to be exact.
Okay.
We've been producing this equipment for a couple of years now, and we're relatively new in the market compared to people who've been in for decades. But the techniques of resistivity is quite old. 1915 was a paper published on using resistivity in an array to measure the ground and determine what's underneath to a small depth.
And so does it tend to be, for example, I was always taught that things like dry walls, for example, have high resistance. Is that the case? Or?
Yes. What resistivity measures is actually the amount of moisture in the water that has dissolved solids in it.
Right. Okay.
The key being it's got to be moist and it's got to have dissolved solids.
Okay.
And they've got to be connected in some way. Bricks, dry walls don't have any dissolved solids or no water in them.
So and just to be clear, so the dissolved solids help with essentially a circuit.
Yes.
And the electricity passes through.
Yes.
Yeah. Okay.
The electricity passes through the ions contained in the dissolved solids in the water.
Okay.
So salty water is much more conductive than distilled water.
Yeah.
Rainwater is quite unconductive, really. It's not until it's seeped into the ground and picked up a bit of mineral content that it becomes conductive. And if there's an area of where the soil changes from, say, very dense clay to sand, then the water can get in quicker and it can conduct slightly easier, so you can detect gradients.
Okay.
But it's about detecting differences as opposed to absolute values.
I see. So this particular equipment here, then, is it a case of you have probes that pass electricity into the ground?
Yes, you use it. 4 probes like this.
Yeah.
You pass current between the 2 outer probes and measure the voltage in the 2 inner probes.
Okay, and that's those sort of almost like someone walking along with a section of fence, that sort of 2 prongs on each side. Sort of.
Yes.
So yes. Okay. Yeah.
In certain conditions, you can use a really good multimeter. But when the conditions get slightly more difficult, you need a much higher grade of multimeter.
Okay.
So if you spent £10 on the multimeter, it's not going to work all the time.
No.
If you spent £600, then it's likely to work most of the time.
Okay.
Our equipment has a much higher voltage than multimeters normally have.
Okay.
So,
And so just out of interest, I mean, if there are any people interested, what sort of price range would this equipment go for?
a complete kit so that you can go out and if it's not a scheduled area, do your own survey.
I like the way you insert that, yeah.
You have to have a license to do it on scheduled land, but if you're a farmer and you have a field and you think, well, there could be something there, or want to find some land drains, then you can buy a complete kit for £1,475.
Okay, cool.
Today.
Wonderful. That's sort of excellent, cool. So if that's the resistivity, when it comes to magnetometry, presumably there's more to it than metals. Now, I kind of know the answer to this already, but just for the people at home.
Yes. In fact, if you've got metal in the field, then you're really in trouble.
Yeah.
What it detects is actually things like bricks.
Okay.
And I have a standard brick here. It's a blue engineering brick. And this brick is very magnetic.
Wonderful. Okay.
If I was out in a field, we could detect the north and south face of this brick. It acts just like a bar magnet.
Okay.
And let's say you have remains of a kiln, and it's been ploughed down to just the foundations. Well, that could be half a ton of quite magnetic clay that's been fired that you can detect using a magnetometer.
Okay. Excellent. And is that because through the burning process, micromagnetic particles have changed their orientation, this kind of thing?
Yes.
Right.
Fired clay is really quite magnetic to unfired clay.
Yeah.
And it also keeps the direction of the firing in it. That's why you can tell which direction this was fired relative to magnetic north and magnetic south.
Yeah.
So the clay becomes more fired clay is very magnetic. It distorts the Earth's magnetic field like the old-fashioned dropping iron filings on a piece of paper over a magnet.
Oh yeah. Or making those faces.
Yeah, that's exactly.
Like,
This equipment is like measuring the iron filings.
Right.
It gives you an idea of how together the iron filings would be and where they'd congregate.
Wonderful, cool. And here I can see, just following the sort of the pattern, is it what's a range from about 2.5 to
2,652 is the complete kit, including software to analyse the results and training on how to use it.
Okay.
So somebody turns up, delivers it to your site, shows you or your group how to use it, loads the results onto your computer, and at the end of the day, you have your results on your computer.
Wonderful. Now, just out of interest, is there typically a specialised sort of after process, as it were? So in terms of data interpretation and management? Or?
Yes. It's relatively easy to go out and collect good quality data.
Yeah.
And the interpretation of what it is, there are hundreds of people here who really like to sell you that service.
I'm sure they would, yeah. I once heard someone charitably say it's sometimes like looking at a Jackson Pollock, unless you know what you're looking for.
That's very true.
Yeah.
There's a lot of mathematical methods you can use to help clear up the data, but there's also a lot of skill and squinting.
Yeah. Squinting, okay, right. Yeah.
I find if you squint at the raw results, you get an idea of what you should be.
I see.
What's there.
I see. Okay, well, that's something I didn't actually do at uni. I just didn't do the squinting, you see. So
I look over my glasses now a lot.
Yeah. Excellent. Well, it's been a pleasure talking to you. Thank you very much.
Thank you very much, Mark.
I was tempted by that. Events archaeology.
I'm here with Claire Graham, and she is from Stratoscan. There is Stratoscan, and she. Well, what is it that you do?
Right here, what we do predominantly underground surveys, looking for any archaeology below the ground, including magnetic data and also GPR that can go down sort of 3-4 metres to look for archaeological deposits.
And GPR is ground penetrating radar?
Ground penetrating radar, yes, that's it.
Uh-huh.
And we also do measure building surveys, historic buildings and things like that.
Right.
We use laser scanning and drones to look at the roof surfaces as well.
I see. So this is actually. That's actually a dot map, isn't it, of the building?
Point cloud, yep, that's point cloud data.
Point cloud
collected
data.
by laser scan.
That's astonishingly detailed.
And this, I think, is a 13th century dining hall within the school, so you can start to pick out all the individual roof timbers and bricks.
Yeah.
Just from the scan data.
So, just to see, how many sort of points of data per unit are there?
Oh my goodness! Now you're testing me, aren't you? Oh, good idea. I don't know. I'm trying to think.
Is it an order of thousands per meter?
Yes, very much so.
Yeah.
Terabytes of data.
Right, wonderful, excellent. Okay, superb. So this sort of service, as it were, is it all about letting people have the tools and then they go away and process the data themselves, or do you also sort of offer data processing?
We do the whole thing. So,
right.
Basically, if you're breaking ground, it's very expensive. So people want to find out what's below the ground before they break ground.
Yeah.
It keeps parklands and farmers very happy if you don't dig and you just do non-intrusive surveying. So we do the whole service, collect all the data, process it, write a report, and then for commercial work it's given to a county archaeologist. A county archaeologist will advise on the level of trenching and things like that.
I see. So I mean, as a friend of mine once said, you can't rewrap the present, as it were, when it comes to an archaeological site. So do you think, in this sense, this sort of recording, but also underground geophysics work is a way of actually helping it so that people in the future get to unwrap those presents, or not even? You may even get so good at this to the point where actually you can get what you need, archaeologically speaking, without actually ever breaking soil, sort of thing.
Well, an archaeologist never agree with you there. They'll always say you've always got to test it.
Well, yes, yeah. I have to.
Exactly.
I'm someone who likes to get a dirty hand, but at the same time, I think there's something to be said for this, sort of, especially, for example, in when it comes to, say, utility mapping, something where it's actually very functional. You need to get something done quickly, and also it's a fairly narrow band that's being I suppose, destroyed in that process. This is actually a really good way of managing that, I guess.
Very much so, and also with with an archaeological site, you're looking generally at targeted areas. So if you've got the geophysics data, so something like this site here, you've got a good overview of what's going on below the ground. Once you start trenching it, you'll never be able to get that information again. So it's great to have that overview, that context essentially. For archaeological science.
So and I guess to continue the present analogy, this lets you see the wrapping before you tear it up. Yeah, I see. Speaking of which, as you may be wondering, this here is a jigsaw. I'm yet to be brave enough to try it out, but apparently you can win a case of wine.
A case of wine.
I thought it was a bottle.
No,
a case of wine. Wow, well, I'll have to give it a go.
I need to make that bigger. Yeah. So we've got this data of a Roman fort. So this is the Roman fort, and we found there was an earlier fort below it as well. So we've got the data, 25 pieces. We're just trying to encourage people to come and have a go, put the data together.
Fair enough.
Bribe them with a case of wine.
Excellent. And you mentioned yesterday, was it 1 minute 56 was the record?
That's the record at the moment. It's faster than me. I haven't even got that.
And you see this stuff every day.
Exactly, yeah.
Precisely. Okay, cool. Well, I'll have to try and give it a go maybe a bit later on.
Thank you.
If I'm feeling brave. Anyway, thank you very much. Thank you.
Thank you.
Oh, actually. I think so. Lovely. I'm here with Adam from Aerial Cam Digital Photography, and this is actually an area which I'm really interested in. I've seen a couple of interesting sort of solutions to this, and Adam has some particularly interesting elements to talk about. So here he is. This is Adam. And Adam, could you possibly tell me a little bit, or tell the boys and girls at home a little bit, about drones in archaeology? What's the advantage?
Okay, well, first of all, I need to go back a bit really. I'm Adam from Aerial Cam, and I set up Aerial Cam as a specialist archaeological photography service 10 years ago. And
10 years?
Yeah.
So I don't mean to sound surprised.
So we started that really with using, so I was working as a field archaeologist and then decided to specialise in archaeological photography. We, at that time, really had only available things like telescopic masts, full-size planes, helicopters, and kites and balloons and things like that.
So just to elucidate, would a telescopic mast essentially be a big pole on which you put a camera?
That's right.
Yeah. Okay.
So I've got, on my Land Rover, which is parked outside, I've got a telescopic mast mounted on that, which goes to a vertical position. We put a camera on the top, we press a button, and it telescopes out up to 20 metres up in the air.
Right,
and then we control the camera remotely.
Wonderful.
From inside the Land Rover, and then we can drive up to the trenches or up to historic buildings and then do low-level aerial photographs using that.
Excellent.
And then over the years, of course, we've used other bits of equipment like kites, and now we've been using UAVs or drones for the last few years, and of course now fully qualified and insured and things like that, and improved by the Civil Aviation Authority to use the latest bits of equipment which give us greater versatility and the ability to get cameras all over and into positions so that we can create 3D models or use photogrammetry or structure from motion in order to create 3D models of the archaeology in the ground or in the historic buildings or the ancient monuments that we're looking at.
Okay. Now, something which I've seen sort of as I've been walking around the event has been the different types of solutions to essentially recording archaeology either in the landscape or, for example, as structures, this kind of thing. Does this have the capacity to sort of to integrate with other technologies as well, using a UAV, for example, or is it a case of it's actually essentially ideally an all-in-one solution?
Well, yeah, obviously, I think any kind of archaeological investigation it requires the use of different tools, and so a greenfield site, we could go along with the drone and do a vertical aerial survey, produce a digital terrain model using photogrammetry of that. We can tease out information of the earthworks that are showing on the surface. We might then also apply things like geophysics to investigate what's under the ground, and we might be able to integrate that then with the digital terrain model. But then really these come into their own when the site is stripped or when the excavation begins, and then we can do aerial photographs and look at the evidence that's in the ground. We can really tease out a lot of information from looking at things from above, and see features and evidence that we can't see from human height when we're actually on the ground. If we look at it from above and look at it with a bigger picture, we can get more information from that.
So in some ways, it's like one of the old problems, or it's still a problem, but one of the old discussions in archaeology used to also always be about getting greater resolution in terms of time specificity of a site or a find or an artifact or something. In this instance, it looks like actually you're adding a different type of resolution and dimension, by actually integrating different ways of looking at a site, interrogating the data, combining it with other forms of data and this kind of thing. Yeah, okay.
Absolutely, yeah. Which may help you then your interpretation of that site.
Yeah.
But certainly, from an archaeological management point of view, you're able to understand what's on the ground, what the evidence is that you're dealing with, and how best to mitigate it. Okay.
So this UAV here then, obviously it's more than just a toy, as it were. I like the way you refer to it as an aircraft, which is probably a very apt description.
Yes.
What would you say are the main things to be aware of if someone is looking to either use one for, or just in any way if they're interested in a drone, whether it's for filming or actually just for casual use? I mean, are there things which are happening now which people need to be aware of? Or?
Oh, absolutely. I mean, really, the main thing is to be safe and legal. Obviously, people's safety is paramount. That's the priority. But also then making sure that you're not in breach of the regulations. If you want to use something like this, you really need to understand what the regulations are and how you use the equipment within those regulations. One of the key things to remember really is obviously safety distances from people, structures, animals, and that sort of thing. But also the fact that you do need to have permission from the landowner from wherever you fly. There is,
and is that a vertical boundary, or is it a line of sight boundary?
I would suggest that it's vertically really, although within the safety distances set by the Civil Aviation Authority.
Okay.
So if you're going to be within 50 metres of a house, for example, and you've got permission to fly in the field, then really you need to speak to the people in that house and let them know that you're going to be there. And if they've got any objection, of course you don't fly. Or you don't fly within 50 metres of them.
And is this typically, literally, out of interest, is this typically for privacy concerns, or might it be that maybe they object in some, because obviously there's lots of stuff in the news at the moment, isn't there? So,
privacy is another factor which obviously needs to be taken into consideration, and more that's becoming important now. But really the safety distances are set for ensuring that damage is not caused to people or property or livestock or whatever. And so
and is that sort of linked with the buffers and boundaries of, say, sudden gusts of wind and this kind of thing?
Absolutely, So they've created these sort of safety distances as
margins,
as a buffer zone. So, and obviously sometimes aircraft do go wrong, so those may not even be big enough to deal with that. But ensuring that you understand your aircraft, how that works, the regulations, getting permission, and ensuring that at all times you're safe.
Okay, cool. Do you want to just very, very quickly just sort of point out some key features on this UAV?
Okay.
Because
I'm just going to turn it on for you.
Okay.
There'll be a slight beep. We've already turned on the radio controller and the app. That we control the camera and get all the information back from the aircraft about battery, distance, height, speed, and that sort of thing. We can see what the camera's looking at. We can adjust all the camera settings. But we actually fly the aircraft using the radio controller with the joysticks. And the aircraft has got the camera, which is on a gimbal, and so when the aircraft is moving, the gimbal stabilises the camera. So whatever the aircraft is having to do to compensate for wind, or for me moving the aircraft to fly it through the air, the camera is always kept pointing in the direction we want it to point in, which is quite often straight down. And we can get lots and lots of stills photographs with photogrammetry, but also we can shoot really high resolution 4K resolution video.
Right. Okay.
As well.
Wonderful.
We've got an example of here.
Yeah.
Which has got some overlays of 3D reconstructions of what this particular structure, Leicester Abbey, looked like.
Yeah. So this was a Dig Ventures project, wasn't it?
That's right.
Yeah.
In Suffolk.
Wonderful. Excellent. Cool. So one final question, and that is, do you think, in your experience so far, that UAVs are being, I suppose, deployed, in that sense, hired by archaeological teams, primarily for survey, or actually for helping, for example, in the case of this video here, to sort of tell the story of the site?
Mostly I would say it's survey work. So we're really being asked. I'm asked to come in and record the archaeology as it's found in the ground, all nicely cleaned up, and we want a record of that. And so by taking lots of vertical photographs and creating a 3D model, we've got a nice record of the evidence in the ground. And in the case of historic buildings and ancient monuments, exactly the same.
Wonderful. Well, and would that typically be the camera down work that you were talking about? Is that typically the perspective that you get?
For the archaeology in the ground, that's generally the camera down photogrammetry, build a 3D model. And of course we can disseminate that information to a very wide audience through online viewers and things like that, but generally it's to produce the data that goes into the reports.
Wonderful. Well, thank you very much for your time. It's been a pleasure. I'll just zoom in on the... I think I might have a look. And here we are at the end of the